I'm going to go over the study guide again. Cumulative test study guide 1A. Okay, problem number 1. It says find the sum, -5 plus 3, use 4 different methods. Now, some of you use different methods, but what are the 4 methods that I showed you? Here they go. I'm going to make 4 partitions. The first method using tiles. -5, 1, 2, 3, 4, 5. +3, 1, 2, 3. Identify the 0 pair. What do we have left? -2. Second method, ground 0. You draw your ground. What is the first number? -5. So I dig a hole of -5. Then +3, that's dirt. That's above the ground. 3 feet of dirt. Question, do these 3 feet fit in here? Yes, the entire thing fits in here, but will it cover the hole? No, it will cover probably up to right there. Yes, something like that. So that means I have a hole left over, which is of -2. Third method, number line. We always start at what? 0. My first number, -5. Going to the left. 1, 2, 3, 4, 5. I land at -5. My second number, +3. From where I'm at right now, go 3 steps to the right. 1, 2, 3. Where do I land? Let's see. -1. So this is -2. And the last method, using the absolute value. -5 plus 3. What is the absolute value of -5? 5. Absolute value of +3. 3. Since they're not the same sign, we subtract. That's 2. Which is the greatest absolute value? 5. What was the original sign? Negative. And that's how you do those. 4 different. We did this almost an entire week at the beginning of the school year. Number 2. Video games. I mentioned this about a store, right? Let's say you have a store. So Emma gets all this inventory received into the store. So all these received are what? Positives, because they go into the store. So what is 50 plus 45 plus 45? 140. Plus everything that leaves the store are negative, because we're talking in inventory. So if they leave the store, are negative. So all of these are negative. So let's see. 28 plus 22, that's 50, 60, 70, 87. So therefore, 140 minus 87, let's see, 87 to 100, that's 13, to 40, that's 53 games left. Make sure you write a statement. Don't just give me a number. You're answering a question. Pretty simple? You're like, really? That's it. Go to number 3. I'm going to zoom in for this one. So the first thing I asked you to do with these, put a 1 on anything that does not have an exponent. When we're multiplying, look for same bases. Are these the same base? Yes. What happens to the exponents? We add 1 plus 2 is 3. Bring down the m to the 8th since there isn't any other. However, if you left it like this, I'm going to take a point because it needs to be in what? Alphabetical order. M to the 8th, n to the 3rd. Make a note for yourself. Put right there. I need to write this in alphabetical. Number 4. Guys, and also if you're doing this step by step, one section at a time, use your colors so you can show colors for one section, a different color for a different section, so you can go, you don't mess up with your organization. For the computation, use your pencil. But I'm saying to show with arrows, use different colors. For example, distribute. So what is 2 times 2, n to the 4th? 2 times -2, n to the -4th. What does this indicate? Multiplication. Distribute, that's m to the -6, n to the +9. Are we there so far? Now I'm going this way. There's multiplication all the way through. Same basis. If we're multiplying, what happens to the exponents? We add them. What is 4 minus 6? -2. Next, are these the same base? Yes. What is negative 4 plus 9? 5. However, can we leave it with a negative exponent? No. Therefore, this one goes to the denominator, m to the positive 2. Remember, because if we do the reciprocal of this, it changes to a positive. You guys see that? Which one stays in the numerator? N to the 5th. Number 5. Once again, what did I ask you to do? Put a 1 on anything that does not have an exponent. Because if you don't, you're going to forget to distribute the power. Did anybody forget to distribute to the 3? Yes, some of you forgot. Here it goes. This becomes 3 to the 3rd, v to the 3rd, w to the 9th, times. I'm going to change colors. V to the 3rd, w to the 3rd. Next, I'm going to simplify. What is 3 to the 3rd? 3 times 3 times 3, which is 27. Are these the same base? Yes. What happens to the exponents? We add them. What is 3 plus 3? 6. Same base? Yes. W. What is 9 plus 3? 12. And we're done. Let's do another one of these. On the side of that, you have space. I want you to write example 5Q. Parentheses 2, x, y to the 2nd, close parentheses to the 4th power, open parentheses, x, y, close parentheses to the 2nd power. Do that one by yourself? Go. All right, here goes the process. For those of you that missed it again, here it goes. Put a 1 on anything that does not have an exponent, or you're going to forget to distribute. There he goes. I'm going to change to red. Distribute. 2 to the 4th, x to the 4th, y to the 8th. Times. Distribute. X to the 2nd, y to the 2nd. Hands if you got it to right there. Okay, good. From there, we simplify. What is 2 times 2 times 2 times 2? 16. Same base? Yes. X to the 6th, because we add the exponents. Same base? Yes. Y to the 10th. Hands if you got that. Okay, good. Let's move on. Number 6. There you go. This one, they said 5.02 times 10 to the 22nd in 1 gram of carbon. But how many grams do they want us to compute? That means we need to multiply this 1 times 800. However, didn't we see this sometime back and I said change it to scientific notation? Therefore, how do we change this? In visible decimal, there it is. Move it how many times? 2. So this is 8 times 10 to the 2nd. Why to the 2nd? Because we moved it twice. From there, we're going to multiply this times this one. 5.02 times 10 to the 22nd. Now check this out. To save time, I'm not going to do the commutative and associative because we already know that that's what we use. But this is what I'm going to do. Aren't these the same base? And since we're multiplying, what happens to the exponents? Add 22 plus 2, that's 24. Times. What do I do with this one? Multiply that times that. So therefore, 5.02 times 8. 16, 0, 1, 40. How many decimal places? 2. So this is 40.16. However, look what it says. Write your answer in what? Scientific notation. So watch. Is this scientific notation? No, I need to move the decimal one more time to the left. That means I need to add 1 here. Therefore, this is 4.016 times 10 to the 25th. Bless you. If that was to be it, that's it. However, what did I underline on some of your study guides? It said, round your answer to 2 decimal places. Look at our answer. Which is the 2nd decimal place? This one, right? Does it stay a 1 or does it go up to a 2? 2, because this one is greater than 5. So this is 4.02 times 10 to the 25th, and its atoms in 800 grams of carbon of C. Does everybody see that the atomic symbol? Yeah. Bless you. Once again, don't forget two things at the end: scientific notation, and then at the end, round to the nearest 2 decimal. Okay? Next, go to division. I'm going to zoom in. Look up. It says, some of them be multiplied on here because you saw parentheses. But what is in between those 2 parentheses? The division sign. So watch. 2.7 times 10 to the 15 divided by 3 times 10 to the 11. Are we there so far? Aren't these the same base? Yes. What happens to the exponents when we divide same bases? Subtract 15 minus 11, that is 4. Times 2.7 divided by 3. I'm going to write it over here. 2.7 divided by 3. Does not fit in there. Bring the decimal. 9 times 27. Subtract 0. So this is 0.9 times 10 to the 4th. Is this scientific notation? No, we cannot have a 0 here. It has to be at least 1 digit. So I need to move it. I'm going to do this in green so you remember. I'm going to move it to the right. If I move it to the right, what do I write here? Minus 1. When we go to the left, it's plus. Therefore, 9 times 10 to the 3rd. Want to do another one of those, or you're good? Okay, let's do another one. Example 7Q. 7Q. I want you to do 4.5 times 10 to the 30th divided by, parentheses, 9 times 10 to the 7th. Go. See what you get. Okay, let's see. So you should have written 4.5 times 10 to the 30th over 9 times 10 to the 7th. Yes? From there, same basis? Yes. What is 30 minus 7? 23. Then we got 4.5 divided by 9. Does not fit in there. It fits in here 5 times. Yes. 45. Subtract 0. So we end up with 0.5 times 10 to the 23rd. Is that scientific notation? No. We move it once to the right, which means we subtract 1. So this is 5 times 10 to the 22nd. Hands if you got that. Okay, good. Move on. Number 8. Once again, these, some of you missed it because you did not do the very first thing I asked you to do, which is what? Put a 1 on anything without an exponent. Please, pretty please, with a cherry on top. I'm going to zoom in. I'm going to distribute the numerator first. That becomes 4 to the 4th, r to the 16th. Are we there so far? I'm going to the denominator. Please take your time like that. Don't rush through everything on the first step. Do numerator first, then denominator. Make sure you're distributing correctly because your noodle gets tired. I get it. And sometimes you forget to distribute to one of them. So here it goes. 4 times 2 is r to the 8th. 4 times 6, that's s to the 24th. Are we there so far? All right, let's move on to simplification. 4 to the 4th is 4 times 4 times 4 times 4, or 16 times 16. What is 16 times 16? 256. All right, are these the same base? Yes, r and r. So what happens when we're dividing? We subtract. What is 16 minus 8? 8. So r to the 8th, which is the only one that we did not do anything with. Leave it where it is. On the denominator, s to the 24th. Some of you brought it next to, and that is incorrect. Leave it where it's at. we need another one of these? Okay, let's do example 8Q. Parentheses, let's do 2x to the 5th over x to the 3rd, y to the, give me a number, 8, close parentheses, to the 3rd power. Copy and go. Take a neighbor, what you got, please? Distribute 2 to the 3rd, x to the 15. Distribute x to the 9, y to the 24th. Simplify 2 times 2 times 2, that's 8. Same base, yes. 15 minus 9 is 6. And this one stays where it's at. Hands if you got that. Okay, good. Move on, number 9. This one, some of you just forgot to go the extra step. But once again, do not forget to put a 1 on the exponents, please. Because then you end up multiplying the numbers. Here we go. 4 to the negative 2 over 5 to the negative 2. Question, can we leave this as a negative exponent? No, so it goes in the denominator. Can we leave this one as a negative exponent? So we send it to the numerator, 5 to the 2nd. That's how they change in symbol. Therefore, what is 5 squared? 25. What is 4 squared? How many times does 16 fit in there? 1 and 9, 16. Double check your work, please. Make sure you simplify to lowest terms. Number 10. Are we going okay? Yes? Am I going too fast or no? Number 10. We did one of these on the warm-up. Here it goes again. What do we do with this? We need to rewrite it. Therefore, this becomes 125 to the 1/3 power times the 2nd power. Is that correct? Why did we change it like this? Because we know how to do radicals using a numerator of 1. So therefore, this becomes cube root of 125. This we raise to the 2nd power. Therefore, what number times itself 3 times give us 125? 5, bring down the power of 2. What is 5 squared? 5 times 5 is 25. Most of you got that one correct, so I'm moving on. Number 11. Here it goes. This one we don't need to rewrite. We just need to change it to radical. This becomes cube root of 64. What number times itself 3 times give us 64? 4. Bring down the plus. Next, rewrite this out of radical. Radical 16. Do I need to write the index of 2? No. One number times itself 2 times give me 16. 4. What is 4 plus 4? 8. Number 12. Here it goes. I'm going to use 3 different colors so you guys can see each part. I'm going to go by parts. I'm going to start with 4. What is square root of 4? Or what number times itself 2 times give me 4? 2. So I'm done with this one. Next. This one has a variable in the power of 2. What's the invisible number here on the index? I'm going to write it so you guys can see it. So now, what do we do with this and that? Divided. What is 2 divided by 2? W to the 1st. We're done with this one. The only one we cannot divide is this one because this one is not divisible by 2. We end up with a fraction. So we need to rewrite this. So I'm going to change color. So watch. An easy way of rewriting these, look up please. Just take 1 away from that power and you write z to the 1st. So if we took 1 away, what's left? Z to the 2nd. Does everybody see that? This 3 became 1 plus 2. Now I put it in a radical form, and I don't use this one. I put the index here. So what is 2 divided by 2? Z to the 1st. We're done with this one. Which is the only one we couldn't simplify? Square root of z to the 1st. Number 13. Start with red. Distribute, distribute. This is a to the fourth. 8 times 1 is 8 divided by 2. That's b to the fourth. Does everybody see how I got that? 8 times 1 is 8. 8 divided by 2 is 4. Okay? Times. That's what it means when they're side by side. What is 9 divided by 9? 1. Yes, question. No, I said 8 times 1 is 8 divided by 2 is 4. Oh, the first one, yeah, my bad. I did that to see if you were paying attention. 8 times 2 is 16. All right, next. Are these the same basis? Yes, so these two become what? B to the 5th, bring down the a to the 16th, and we're done. This one we did on the warm-up, but here it goes again. Process. Degree of the first one, 2. Of the second term, 0. Of the third, 5th. Of the fourth, 3rd. Of the 5th, 4th. And on the last one, to the 1. Which is the highest one? 5. So I write 2x to the 5th. Which was the next one? Plus 9x to the 4th. Which was the next one? Negative 9x to the 3rd. Which is the next one? Negative 2x to the 2nd. Which is the next one? Negative 10x. And which is the last one? To the 0, plus 8. This is what? Standard form. That's 1 point. Next, leading coefficient. You look at the first term once it's in standard form, and what number is multiplying the variable? 2. If it doesn't have a number, then it's obviously an invisible 1. So 1 point here, 1 point here. I'm missing the name. What is the highest degree? 5th. There, that means it's called a quintic. Let's see. How many terms? 1, 2, 3. If it's more than 3, then therefore it's a polynomial. All right. I'm going to upload the video at the end of the day. I still have some more problems to go. I'm going to go start with those on the next period. So like that, you guys can have the entire video uploaded by the end of the day. Home plate, study. Do it on a separate sheet of paper so you can do all the problems again. Have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye. And I'm going to continue recording. This is problem number 15. Let me zoom in. Add or subtract. Here we go. First of all, do we have addition all the way through? Yes. The only thing, this one's subtraction, but I'm going to keep it as a one term, so watch. This one is like this one, isn't it? So I'm going to write 10n plus 1n. Next, this one is like this one, isn't it? Plus 10n to the 4th minus 7n to the 4th. Are we there so far? What property allowed me to move things around? Commutative property of addition. Next, combine. 10n plus another n is 11n. Next, 10n to the 4th, take away 7n to the 4th, that leaves us with what? 3n to the 4th. Now, why can I combine this one with this one? Because these are dolphins and these are dogs. Can I combine dolphins with dogs? No, according to the lesson that I presented, right? That means this is the answer. Yes, Julie.
You said I got that one wrong.
Let's see.
Right here.
Oh. So up to right there, it's okay. However, is this in standard form? No, standard form is from highest degree to lowest degree. What is the degree for this term? And this one? So which one would go first? This one and then that one. For this parte, I'm not going to be checking that you change it to standard form. But after this parte, start getting used to changing all polynomials to standard form. Everything understand? All right. Any questions with this one? Let's do another one because I sense a disturbance in the force on this one. So you have space right there. I want you to write 15Q. Do this one by yourself. Let's do 9A plus 12. Let me move this over. Sorry. 12A to the third minus 10A plus A to the third. Go ahead, do that one by yourself. Go. There it goes. So we got 9A because this one is the same as that one minus 10A. Next, this one is the same type of that one. So we got 12A cubed plus 1A cubed. Are we there so far? So what is 9A minus 10A? Negative 1A. What is 12 plus 1? 13A cubed. And those of you that went the extra step, then you could have written it as 13A cubed minus 1A. But for right now, I'll take this one. That's fine. Hands if you got that. Okay, good. Let's move on. Number 16. Look at 16. Let's see. Do we have subtraction in between these two expressions? No, it's addition. Do we have a number outside of the parentheses? No. Therefore, we can move stuff around. So let's see. Is this the same as this kind? Yes. So they're like terms. So 7e to the second plus e to the second. Is this a like term as this one? Yes. E, negative e, plus 8e. And then at the end, we bring down the what? Negative 4. Okay. So what is 7e to the second plus 1e to the second? 8e to the second. What is 8e minus 1e? 7e. And then bring the negative 4 down. Can I combine these two? Talk it over with your neighbor. Why can or can I combine those?
Because they have different.
That is correct. These we cannot combine because they have totally different exponents, even though they're the same variable. Do we need another one of those? Julian.
I have a question.
Question, go.
You did it wrong on 16 as well. Why did you write it?
It is? Let me see. Okay, not that. Oh, no. Because you didn't show me work. You see what I'm saying? All right. Another one of these, or we good? Okay, let's do another one. Number 16Q. 16Q. Copy this. Let's do parentheses. 9A to the third minus A, close parentheses, plus, open parentheses, 6A plus 2A to the third minus 7. Let's see what you get for that. Go. Okay, here we go. Do we have addition between both of them? Yes. Is there a number outside the parentheses? No. So I'm going to start with this one. Which one is like that one? That one. So I'm going to write 9A cubed plus 2A cubed. Which one is like this one? This one. So I'm going to write negative A plus 6A. And then I bring down the what? Negative 7. That was commutative property of addition. Then I combine these. What is 9 plus 2? 11A cubed. All right. What is 6 minus 1?
5.
5a. And bring down the
-7.
hands if you got that. That is correct. We can't combine anything else. We're done up to right there. Okay? Let's go to number 17. For number 17, you guys need to know your properties, guys. If you don't know your properties or you haven't studied them, then, I mean, because we pretty much give you the answer here on these. So here we go. Let's go over these. Look at this one. Are these the same base for A? Yes. So since we're dividing, what happens to the exponents? Subtract. 10 minus 5 is 5. Did they use it correctly?
Yes.
Yes. All right. This one, power of powers. What happens to the exponents? They multiply. What is 8 times 3? 24. Did they use it correctly? No. Look at this one, negative exponent. Can we leave it as a negative? No. So what would be the reciprocal? 1 over 10 to the positive 4. Did they use it correctly? Yes. Product of powers. Are these the same base? Yes. When we multiply, what happens to the exponents?
They
Add. Did they use it correctly? Yes. This one, power of powers, this is 6 to the 0. Question. What is anything to the 0 exponent? Tell your neighbor.
1.
1. And is this one used correctly? No. So this is no. Check your work, please. All right. That was 17. Let's go to 18. Definition. Real numbers. Any number.
Can we write it down?
No, you should have it. You guys should have this, right? Real numbers. Any number that can be represented on, check this out, some of you just wrote number line. Is that correct? No, it has to say what? Real number line. If it says just number line, then I'm going to dock you a point because we understand now that we have real numbers and imaginary numbers. Is that correct? All right. 19. Exponential expression. A numerical or variable expression raised to a power greater than 1. Yes? All right. Number 20. Here's where some of you start getting a little confused. First, write the properties. Product of powers. If you don't have them, write these down. Product of powers, power of power, and then power of product. So what does product mean? Multiplication of powers. 3 to the 5th, 3 to the 2nd. So what is this? We add the exponent, so this is 3 to the what? 7. Whenever you start a property with the word power, that means you need to start the example with a parenthesis. What goes inside? A power. That means one of these. I'm going to write 3 to the 5th. Raise that to another power, and I'm going to say to the, give me a number, Julian?
2.
6. All right, so then this becomes 3 to the 30. Yes? Now look up really quick. This is called product of powers, right? What is this one called? Power of products, which is almost the same thing, right? So watch. I start with a parenthesis and I use this example. 3 to the 5th times 3 to the 2nd, but now I raise it to a power. That's the power of products. So this is 3 to the 50 times 3 to the 20. That's using that property. But can we simplify that? Yeah, 3 to the 7th. Check your work. If you don't have it, copy that example, please. Okay, let's go to number 21. 21, there's two properties. Since it's division, we always started with what? Quotient of powers. And this one is backwards. It's power of quotients. What does quotient mean? Division, doesn't it? So here we go. I'm going to make a fraction here. 3 to the 8th over 3 to the 2nd. Are we dividing powers? Yes. Are these the same base? Yes. What happens to the exponents? Subtract. So this is 3 to the 6th. Now, check this out. Quotient of powers, power of quotient. Look at the previous one. Product of powers, power of products. I just used this same example and I put it in the parentheses. Now look what I do here. Quotient of powers, power of quotients. I'm going to use this example, but it's starting with what? Power means start with a what? Parentheses. Parentheses, 3 to the 8th, 3 to the 2nd, and raise that to another power. I'm going to say 10. So this becomes what? 3 to the 80 over 3 to the what? 20. Can we simplify this? Yeah, 3 to the 60. Once again, if you don't have that, copy that. And number 22. Yes, sir.
I thought it was pretty bad.
Oh, okay. Julian, go.
A polynomial is a monomial or difference of a monomial.
Okay, close. It is a monomial. You started off well, and then you said sum or difference. Check this out. Of monomials. Monomials. It has to be plural because you can't sum or difference only one monomial. It has to be at least two or more, right? You understand?
Yeah.
So it could be a monomial or sum or difference of monomials. Okay? How are we doing? Good? We're going to ace this? Yes?
I'm not sure about acing.
What?
I mean, I already showed you my teacher. I have like a lot wrong.
Okay, all right. We're going to continue, but I'm going to stop the video, and it's going to be uploaded at the end of the day. So if you want to go to the YouTube channel, the latest video will be up there. Again, as I do every year. Yeah? Okay, enjoy your studying. Have a good one. See you guys tomorrow. Bye.